the LeetCode coding challenge, and today we are going to solve our next problem statements. Maximum twin sum of a linked list. Let's start. In a linked list of size n, where n is even, the ith node 0 index of the linked list is known as the twin of the n minus 1 minus ith node. If ith greater than equal to 0, less than equal to n by 2 minus 1. For example, if n is equal to 4, then node 0 is the twin of node 3, and the node 1 is the twin of node 2. These are the only node with the twin for n equal to 4. The twin sum is defined as the sum of a node and its twin. Given the head of a linked list with even length, return the maximum twin sum of a linked list. So we have given a linked list whose size will always be even, and we need to find the twin sum for the maximum twin sum for the linked list. For any node I, particular node, value at particular node plus if n is the size of the node, n minus I minus 1. What is the meaning of this? Suppose we have the node given. For first node, the twin sum will be x1 plus x6. For second node, it will be x2 plus x5. For third node, it will be x3 plus x4. So for first node, first plus the last node. For second node plus the second last node. For third node plus the third last node. And we need to find the max out of it. So let's try to solve this test case. 5, 4, 2, 1. And one more thing, we only need to do this computation till the half of the linked list. So our linked list is even. We need to only do the part till the half, because for the rest part we have already done the computation, right? So 5, 4, 2, 1. For the first index, the twin sum will be 5 plus 1, 6. And for second one, it will be 4 plus 2, which is again 6. So the maximum will be 6. For second one, 4, 2, 2, 3. 4 plus 3 is 7. And for second and the second last node, 2 plus 2 is 4. But maximum is 7. There is only 2 nodes, so simply add it. So now let's discuss the solution part. How can we solve this problem statement? Suppose we have given this node, this linked list 5, 4, 3, 2, 1, 0. What we can do, we only have the head pointer that is pointing to the first node. To solve this problem statement, we can break our linked list from the middle. So if we break our linked list from the middle, 5, 4, 3. So it is an even length linked list. So there are two middle. One is 2 and another is 3. So we need to find the ceiling version. Ceiling version, whatever is n by 2. So the length of this node is 6. So 6 by 2 is 3. So, but the indexing starts from 0. So 0, 1, 2, 3. So it is correct only. We do not need to do ceiling version also. Simply do n by 2. So 6 by 2 is 3. Right? And because our indexing starts from 0 itself. So we break our linked list from the middle. So 5, 4, 3. And similarly for the another list is 2, 1, 0. Right? Now the second list, the second half list, we can reverse this second half list. So if we reverse it, 0 now, write it like this. Now 1 is pointing to 2. And 0 is pointing to 1. So we have to reverse our list. And now simply we can write it here. 0, 1 and 2. And then we can do the sum easily. So 5 plus 0, 5. 4 plus 1 is 5. And 3 plus 2 is also 5. So maximum is 5 for this output. But what are the two steps that we have done? First, get the pointer from middle of list. First we need to find the middle node, and also we are not using any extra space in this problem statement, so we need to only get the pointer from the middle. Then what we can do, we can reverse the rest list, then reverse the second half list, then calculate max. You can iterate on the first left half linked list and the right half linked list, and keep on finding the maximum value. So yeah, let's do the coding part now. We need to perform two operators. First get the pointer from the middle of the list, then reverse the second half list, then we can easily find the maximum twin summing. First write the logic to get the middle of the list. How can we do it? We can use two pointer approach. So we can have two pointer, one is middle and another is the front. So middle will go one step forward, but our front will go two step forward. So one pointer is only jumping one node forward, but another pointer is jumping two step forward. So we can write it here also, x1, x2, x3 and x4. So initially middle will equal to 0 and front will always also will equal to 0. But at the next iteration, middle will go to one index x2, but front will reach to the next index. Two step ahead to second index, to x3. And in the next iteration, our middle will go to the second index, but our front will go to the two step ahead again, but it will reach to the null value. Then we can stop our processing as soon as the front reaches the end of the node. But by doing this, we will always reach the middle of the node. So now our middle is pointing to the x3, which we want. So let's implement for this part. Define the two pointer. One is the middle node and another is the front node. We can initialize it with the head node. Then iterate over your linked list. So while front is not equal to null and front should next value should also not be equal to null. So if it fulfills any of this condition, it means it reaches to the end of the list. We are moving our middle pointer one step at a time. So middle equal to middle dot next. But we are moving our front pointer two step at a time. So front dot next dot next. Now we know that we have reached to the middle. Now we need to do the second part, divert the second half list. For this we will use the recursion approach. And I have covered this part in the last video. So you can check it from there also, how to do the reverse of the list. For this we will use the recursion approach. So we will define a static method, static void reverse our string. We only going to reverse the left part. So x3 in this, suppose this is our string, so our new string will be, if this is our linked list, after doing the reversal our list should look like this. So only the right side parts would get reversed, and we have the pointer to x3. So to take the list node, let's say head. Now reverse it. Head should not be equal to none. Head equal to none, or head dot next equal to none. return head, linked list last node, reverse of head dot next, return last node, and now do the reversal part. So head dot next. So suppose we have at x3, so we need to point x4 to x3, and x3 should point to null. So head dot next means x4 dot next should point to the x3 and make your x3 next equal to null. So now the linkage between x3 to x4 is broken, but a new linkage is found. Now x4 is pointing to x3. So our reversal code is also done, and you can check this code in my previous video. I have thoroughly explained how to write the reversal logic. Now reverse your list from the middle pointer. Now your list is reversed. Also remember, we have passed our middle pointer. So our returning node, we have passed the x3 pointer, but we have reversed it and return the last node. So now again we have the last point. Again we have the middle pointer. So we have middle pointer now. So now we have head pointer that is pointing to x1 and middle pointer that is pointing to x4. Now you can iterate it and simply add it and find the maximum twin sum. So while our mid is not equal to null, define your max twin sum variable, initialize it with 0, move forward and our linked list is even. So our number of left side node will be equal to the number of right side node. So iterate over the your middle node to the end and take the sum. First we are moving forward our middle node every time, and we are moving forward our head node also every time. We can use the temp node also, so that we do not use we do not lose the access of the first node. So define some temp variable. Instead of using the head node, we are going to use the temp node. Move your temp node from far forward every time. Find the max sum. So max sum equal to whatever is maximum of the current twin sum and the previous twin sum. So mid dot well plus temp dot well, comma our previous twin sum max sum. Now we have calculated the max sum, return the max sum. So yeah, our code is done. Now let's run the test case if it is working. Do we have some compile time error? Okay, sorry, we have need to change it to list node. So yeah, our test case is working. Now let's submit the solution. Our solution is also working, and thanks for joining the session. Let's meet tomorrow.